Hi everyone, welcome to Numpy crash course. Numpy is a Python library used for working with arrays. In a data science field, it is quite widely used. You can create a multi-dimensional array with the Numpy, including one-dimensional vectors, two-dimensional, three-dimensional, or how many, whatever dimensions you want. All those vectors you can easily create and manage. A Numpy is quite fast library. It helps you to work with the matrices and the vectors. It provides a lot of useful functions which we will be discussing throughout this crash course. Basically, you can say that all kind of the linear algebra functions, Fourier transformations, the working principle with the matrices, all these you can do with the Numpy. So if you have installed Anaconda, it automatically install Numpy, but you can install Numpy by writing here pip install Numpy. Alright, so we have already installed, that's why we are not going to install a Numpy. We can simply import Numpy by writing here import Numpy as NP. Alright, so generally in a data science field, we say that Numpy as NP, although you are free to use any numbers there. I mean to say that any variable or any shorthand notation there. Let's go ahead and see how you can create arrays, and before that let's see which version of Numpy we are using currently. You can simply write here np dot double underscore version. It says that currently we are using 1.2 1.5 version. That's the Numpy latest version which we are using. Let's go ahead and create the array with the Numpy. You can simply do here a equal to np dot array, and inside this you need to provide here a list type, or you can say that any vector. So the vector could be a set, that could be a tuple, or that could be a list itself. For example, you can provide here a list 1 2 3 4, and now you check the a becomes here a Numpy array. You can also print here the type of a. It says that this is a Numpy n-dimensional array. And if you want to check the shape of this array, you can simply do here a dot shape. It says that the shape of this array is, there is the 4 element. All right. So when there is the comma, there is the nothing. That's when that is the one-dimensional vector. Otherwise, you can do like a dot ndim. All right. So the a dot ndim so says that what is the dimension of this vector. So ndim says that this is the one dimension vector. You can create here a multi-dimensional vector, but before that, let's go ahead and see if we replace this list with the tuple, then what happens? The tuple is there. You need to just replace the square brackets with the parenthesis, and if you run this again, we are getting the same result. There is no difference. So you need to just provide here a list like object that will automatically get converted into a Numpy array. Alright, so we created here a one-dimensional array. Let's go ahead and see, can we create a zero-dimensional array with the Numpy? Yes, definitely. So the zero-dimensional array is actually a constant value which is a scalar. For example, if I say here np dot array, just you give here a single number, then this number becomes here a constant. I say here a equal to like this, and I print here a and the type of a dot shape, and then a dot ndim. Let's go ahead and print all these things and then see what it is printing there. So the shape of this array, it is saying that the empty, that means there is no shape because this is a scalar value. A scalar value does not have any shape and does not have a dimension because it is a scalar. That's been a single constant value. That's the zero dimension vector. You can see that. Let's go ahead and see, can we create here a one-dimensional? So one-dimensional vector we have already created, so no need to repeat this same thing again. Let's go ahead and see for a two-dimensional array. So the two-dimensional array is something where a value or a vector will be projected into a two dimension, alright, like x and y dimension. That means you need to provide here a list of one dimension vectors. So the two dimension vector, or you can say the two-dimensional Numpy array, is the vector of one dimensional array. That means this is the one dimensional array. Suppose that this whole thing is one dimension. So we are going to create the list of the list. It will become the two-dimensional vector. That means A equal to np dot array. So in this we are going to create a list of list. That means a list of one dimensional vector will become there a two-dimensional vector. If we do the same thing here again and we print here A, now you see there this array becomes here a two-dimensional vector. You can simply do here like a dot shape, a dot ndim, and we can clearly see there the dimension of this vector has become there 2 and the shape of this array has become there 2 cross 4. So the 2 cross 4 says that there is the 2 row and 4 column there. If you count 1 and the 2, 1, 2, 3 and 4 column there. Let's go ahead and see how you can create a three-dimensional vector. So a three-dimensional vector is actually a vector of the two-dimensional array. Or you can say that this is list or vector of 2D list, or you can say that the vector. That means we have this two-dimensional list, and if we create this list of the two-dimensional list, then it will become the three-dimensional vector. That means A equal to np dot array. There you need to provide here a list of the list. That means a list of two-dimensional vector. So this is the two-dimension vector. Let's go ahead and paste this same value again. Now we have here a list of the two-dimensional vector that becomes a three-dimension. We can simply print this A. We see there this has become a three-dimension. Or you can recognize a dimension of vector by counting the number of closed braces there. These square brackets or opening brackets. This is opening brackets and these are the closed brackets. So the number of brackets, if you count at the start, that says that the dimension. Or you can say that here a dot shape, a dot ndim. So it says that the shape of this vector is the 2 cross 2 cross 4. That means it says that there is the 2 vector which has 2 row and 4 column. That's when there is the 2 vector. The one vector is here, another vector is here, and these 2 vector, out of these 2 vector, each vector have 2 rows, 1 and 2 rows, and the 4 column, 1, 2, 3 and 4 column. And then this 3 says that the dimension. So obviously the dimension is 3. Otherwise you can count here the length of this tuple. That will say that the length, right? So that means length of a dot shape. This will say that the dimension of the vector. And similarly you can create the 4-dimensional vector or 5-dimensional vector, or how many dimensions you want, you can decide. So the moreover, if you say that the n dimension vector is actually a list of or vector of n minus 1 dimension vectors, like a 3-dimension vector is the list of the 2-dimension vector. Similarly, n dimension vector equal to the list of n minus 1 dimension vector. Alright, perfect. So this is all about in this lecture. Thanks a lot for watching this. I'll see you next one. Hi everyone, let's go ahead and get started with the array indexing and slicing. We have previously seen how you can create 1-dimensional, 2-dimensional and 3-dimensional vectors, and we also saw the method as many dimension you want, you can create your vector. But the question is here, how you can index your array. I mean to say that if I ask you to get a value from a particular dimensions, how would you get that? So we will start with the first dimension vector. Let's go ahead and copy our first dimension vector. which we had here. I'm just going to copy that and paste it here. That is the A. The dimension of A is the one dimension vector. For a 0th element, that's mean the element which is at the first index here, which is referred with the 0. So its indexing starts with the 0 and length minus 1. That means there are 4 elements. Indexing will start with the 0, 1, 2 and 3. Alright. So the A0 is 1. That is the first value. That is also known as 0th index. And the first A1 means second value. You should be getting here 2. And if I say here A3, you will be getting the fourth value. So whatever the number is here, you just add plus 1. So that's the value you will be getting from that index. 0, 1, 2, 3. Alright, the 3 means a fourth value. Let's say if you don't know the length of vector and I ask you to get the last value, then how would you get that? You need to get here, you need to do here reverse indexing. That means a minus 1. So the minus 1 means start in reverse order and get the first value. Do remember here, a reverse indexing does not start with 0 like a forward indexing starts with the 0. In reverse, you start with the minus 1. A minus 1 says that get the last value, and minus 2 says that get the second last value, and minus 3 says that get the third last value. Alright, that's how you can do the indexing of the one-dimensional array. Alright, let's go ahead and see the two-dimensional vector, how you can access the indexes of the two-dimensional array. We are just going to copy the previous two-dimensional array, which is 1, 2, 3, 4, 1, 2, 3, 4. Just for simplicity, I'm going to say here 5, 6, 7 and then 8. So that you can know properly which index we are going to refer there. Alright, let's go ahead and print this value so that it will be a little clearer to you. This says that the rows, so there are 2 rows and 4 columns. I ask you to get the first value, that's mean this value. How would you get that? A0. Alright, but you didn't get that. Alright, that was the expected. You know the problem is here. When we were working with the one-dimensional vector, then one index was sufficient to get the first value. But when we are working with the two-dimensional vector, then it needed 2 indexes there. Similarly, if you are working with the three dimension, then you need a 3 index there, or n dimension, then you need a n index there. Since it is a 2 dimension, then you need here a 2 index. And those 2 index you can provide with the comma. That means this 0 starts with the 0. Alright. It says that the first row and first column. So the first row, first column, that's mean the index 0 and 0. Then you will be getting this value. Alright. Here you got this value. Just to make it a little more clearer to you, you just print here A0. A0 means the first row. A1 means second row. So if I print here a first row, now this becomes a one-dimension vector. Now in this you can apply one-dimension indexing to get the any of these value. Now if you consider this A0 as the one-dimension vector, then obviously by referring the concept what we learned earlier, to get the first value, you need to provide here a 0th vector there. Alright, something like this. Do you see the beauty of these 2 lines of the code? You can provide the 0, 0 with the comma. Otherwise, you can provide here as the individual index there. So this A0 gets a one-dimensional vector, and then the next 0 gets the first value of the one-dimensional vector. That's when this one. Let's suppose that again we try to evaluate A0, we get the first row here, and now I ask you to get the last element. Alright, if you consider this vector as the two-dimensional vector, then that could be a little complicated to you. But if you take the A0, that's in the first row, then it becomes here one dimension vector, and as you know, to get the last value you need to just put here a -1. So you will be getting here a last value. Similarly, you can remove these two brackets and you can replace these two brackets with the comma. You can get it like this: A0 -1, that means 0, comma -1. That means we are taking here a first row, and in the first row last value, which is this one. Let's go ahead and print it. Now you see there, just for a simplicity, let's go ahead and comment that one. Now you see this one is getting printed here. The value is 4. That means for both of these it is giving us a right result of 4 and 4. Perfect. Let's go ahead and see how we can access a 3-dimensional vector. We need to first create a 3-dimensional vector. So we are just gonna copy the earlier vectors and then I'm gonna paste it here. The earlier vector, now I need to change its value. So I make it like 11, 22 and then 33, 44, and here I make it 10, 20, 30 and 40, and then here I'm gonna make it like 100, 200, 300 and 400, so that we have here a distinct value, and when we access these values it would be more clearer to us which value we are accessing here. Let's go ahead and print this A. So if you remember, in a previous lecture I told you a 3-dimensional vector is a collection of the 2-dimensional vector, and 2-dimensional vector is the collection of the 1-dimensional vector, and 1-dimensional vector is the collection of a scalar or 0-dimensional vector. So to access this a 3-dimensional vector, you can simply convert it into a 2-dimension, and then you can access the values like we accessed in our 2-dimensional vector. For example, if I ask you to access this value, do the indexing to access this value, then how would you access this value? First of all, you need to know that how many rows, how many columns and how many dimensions are there. That you can do like a.shape. It says that there are 2 cross 4, there are 2 cross 4, alright, these are the 2-dimensional vectors, and then there are the 2 rows, there are 2 dimension. So it says that there are 2 dimension for a 2 rows and 4 column vectors, and I ask you to access this one. So this one is the second dimension and first vector, alright. So how you can access that? You can write it like this: A0 means this first row, alright. So you will be getting this one: 1, 1, 1, 2, 3, 4, 11, 22, 33 and 44. But we want to access this one, that means that is the A1. So A1, now you got this whole vector, alright. Let's go ahead and do the indexing to get this 1-dimensional vector. So out of these, now you can provide a 0 for a 0, that's mean this indexing, and 1 means this one. So if you provide here a 0, now you got this vector. Again, you got here a 1-dimensional vector, and I ask you to access this 40. So there are 2 ways to access. Either you can provide here the index in a forward mode or index in a reverse mode. If you provide index in forward mode, 0, 1, 2 and 3, that means you need to provide here 3. Otherwise, you can provide the dimension indexing in reverse mode. So you can provide there a -1. That means we are accessing it from the back side, the first element from the back side, which is the 40. Perfect. Till now we have been accessing a single value from the vector, but there are ways to access these values together. I mean to say that you can access multiple values together. For example, if I ask you to access these 2 middle values at one time and these 2 middle values at one time, then how would you do that? It's pretty much simple. So since these two falls into a second index, then you need to provide here A1. Now I asked you to access these and these. That means I asked you to access these values from all rows. So if I say for all rows, then you can simply provide here a colon. So the colon means we are going to access from all rows, and then for individual vectors we want value from second and third one. Alright, that's in 0, 1 and 2. So we need 1, 2, 3. Do you remember, if we access 1 to n, we access the values from 1 to n minus 1. That means we need to get it here from 1 to 3. That's mean just before 3. That's mean 2 and 0. It's like this, 1, 2, 3. If you do that, you will be getting the values which I told you earlier. That means you are getting here 20, 30 and 200 and 300. Alright. So similarly, you can do for 1 dimension and 2 dimension or 3 dimension or as many as dimensions you want. Alright. This is all about in this lecture. Thanks a lot for watching this. I'll see you next one. Hi everyone. Let's go ahead and get started with the Numpy data types. You can create array with the predefined data types. Earlier we had seen some arrays creation, but we did not define any data types while we were creating these arrays. But you have options to provide the data types while creating these arrays. If you pass a d type as I, that means integer. If you pass it as a b, that is boolean. Otherwise you can pass as unsigned integer, that value which ranges from 0 to unsigned integer range. Let me see it. I don't exactly remember. Int range. The value starts from, these are the unsigned integer, 0 to 65 or 0 to this one, depends the number of bytes we are using. Then we have a float, a complex float, time delta, the time delta where you have a difference of time to define, a date time variables or object. O means the object, which says that it is a string or any other kind of the objects which might be unknown to a NumPy, and then it has the string, it has the Unicode string, and then fixed chunk of memory for other types. Alright, let's go ahead and create an array and investigate its data type. For example, I say here A equal to np.array. Inside this, I need to pass here a list or set to create the array. I say here 1, 2, 3 and 4. And this array is created, but we did not pass any data type. So by seeing this data, we can say that it is the integer, but we don't know definitely what type of the data this NumPy array has created. That you can know by typing here a dot d type. D type says that the data type of these objects or the items which are inside this a NumPy array. It says that it is int 32, that means it's a 4-byte integer. And if we provide here a float value inside this NumPy array, then this data type changes. Now you see, we just provided only one float value. Even after that, this data type got changed to the float 64. Because if there is any float value in your data set, then it will automatically convert all these values into a float value. So it got converted all these value into a float value. And in a Python, if it is 0.0, then Python does not print these values. It just put there a dot to signify that it is a float value. Let's go ahead and create here a string and then see the data type of the string. It is very important to see the data type of the string. For example, I have here the apple and then here I have a banana. It has a very interesting fact which I'm going to show you. Do you see there, once we printed this, it says that it's a U6. Alright, do you see there? So earlier we saw that U is a Unicode string, that is okay. But what is this 6? That we don't know. This 6 actually says here that the maximum number of the character present in this string is a 6 character. Now you see there, we have a 5 here and 6 here. If we make it 7, then let's go ahead and see. You see there, the Unicode character 7. So basically it says that the data type of this NumPy array is U, that is Unicode string, and then this 7 says that the maximum length of any item, which is 7 currently for this particular list. Alright, let's go ahead and see how we can create a string type of the data. Alright, so we did not pass here any data type and it automatically created here Unicode string. But if we pass here a data type, then we can tell NumPy to convert it into a string. For example, if I say here S, you see there the capital S was for a string. Now if you run this, it says that this is for string and the maximum number present there, that is the 7. Let's go ahead and see if we can convert this as the integer data type. And we are going to pass here d type equal to I. That means it is integer. I4 means a 4-byte integer. And if we run this, it says that invalid literal for int with base 10 for apple. Basically it is saying that this apple cannot be converted into integer. And this 4 denote that we were going to convert this into a 4-byte integer. Like here it was saying the maximum number of characters 7, one character is represented with 1 byte, that means it's a 7-byte representation. Let's go ahead and if we convert it 0 and 1, then what happens here? You see np.array is 0 and 1 and d type is I4, that means we are going to convert it for a 4-byte integer. Let's go ahead and run this. Now you see there, this got converted into an integer and we can print here the data type of this array, which is int 32. Alright, so with the help of d type, you can control the data type of the generated array. Let's go ahead and provide here f, which denotes a float. Now you see there, this 0 got converted here into a float and then this got converted here into a float value as well. What happens if there is 0.0 something like this and we want to convert it into a float? It works perfectly here. And if I try to convert it into an integer, this does not work, because if you have seen previous lectures where I taught you a crash course for a Python, in that I told you there, if you have a float string and you want to convert that into an integer, then you cannot directly convert that into an integer. You need to first convert that into a float and thereafter you can convert that float into an integer. That means to get it converted into an integer, you can simply type here a dot as type and then here you need to pass here I, which is integer. So whenever you have a float string, you need to first convert it into a float and then convert back that float into an integer. Let's go ahead and try to convert now this integer value b equal to something like this. If we have, let's go ahead and convert back this to a float. You can simply write here as type f, that is float. You can simply type here s, which is actually a string. You can simply type here u, which will say that it's a Unicode string, and 11 says that it got converted with the 11-byte string. All right. 11 byte Unicode string. Alright, and this one also got converted with the 11 byte Unicode string. Let's go ahead and convert this with the boolean, and if you convert it here bool, that is the boolean. A 0 says that a false for a boolean, and 1 means it is true. You can also convert in a string by typing here str, which is actually a string there. Str is a Unicode string there. Alright. Let's go ahead and see if you have array, then how you can sort your array in ascending and descending order. For example, you have array A equal to np dot array. I'm gonna just create here 1, 22 and some random numbers here. Alright. This random number, I want to sort it into ascending order. It's pretty much simple. You can simply write here a dot sort, then this a will be sorted, the result will be placed here into a itself, then you can print a. Now you see that the a is sorted into ascending order. Ascending order is that where you get the low value first and the high value at the last of the index. But what happens if I ask you to sort this into a descending order? There is no parameter to pass in a Numpy to sort it into descending order. So there is work around to sort it. Alright. So you can write here np.sort, and then I'm going to pass here minus a. Minus a says that it will be sorted into a negative. But these minus we need to remove. That means I am going to again put here a minus. So this shorthand notation works as a sorting of array into a descending order in a Numpy. Alright, this is all about in this lesson. Thanks a lot for watching this. I'll see you next one. Hi everyone. Let's go ahead and get started with Numpy NaN and Numpy INF. So the NaN is not a number, INF is infinite number. So when Numpy says that this is not a number, that's mean for a Numpy it is unknown data type. And when it is INF, that means for a Numpy it is some value which is beyond the calculation, that means which is infinite. Alright, and you cannot compare these NaN values together, but you can compare these INF values together. Logically this doesn't seem correct, but that is how Numpy works there. For example, if I say here np.nan, you see there it says that this is not a number. And if I take two numbers np.nan, I compare these numbers, it says that these are false. That means it is saying here these two numbers are not equal. Otherwise, you can take it something like this: a equal to np.nan, b equal to np.nan. You print here a and b. Now you see here both numbers are nan, and if you compare here a equal to b, you will get here a false, or whatever the comparison you put here, you will get the false, because this cannot be compared with each other. Let's go ahead and see how we can compare np.inf together. I get here a equal to np.inf, b equal to np.inf. Then I say here a comma b. It is saying that these two values are infinite. Let's go ahead and compare these two values. I say here a equal to b. It says that it is true and a greater than b is false. So what happens here in Numpy, when it is INF value, then Numpy says here you can compare these two values together but not the NaN. There is another data type in the Numpy which is none data type. This one is also a data type in Numpy which is none. you check here the type of none is none type. You can also compare these none type to each other. For example, n is equal to none, none equal to none, that's mean it is a true. You cannot say that none is greater than none. Alright, so there is just equal to operator. It does not support greater than or less than. It only supports here equal to, which says that it is a none there. Let's go ahead and create a two-dimensional array here. A equal to np dot array. A two-dimensional array is a vector of a list of one-dimensional array. That means I'm going to say here 1, 2 and 3, and then I say here 4, 5 and 6. Now you see there a dot shape is 2 cross 3, that's mean 2 rows and 3 columns are there into A, which is a two-dimensional array. Now I'm going to replace here these two values with the INF and NAN number. That means I need to say here A 0 1. Alright, so I'm going to say here A 0 1. That's when I'm saying this value equal to np dot nan. Then I say here A 0, that's mean this one, and then this value. I say here 0 and then 2 equal to np dot inf. So it says that cannot convert float nan to integer. So what happens here, the array which we created earlier, the data type of that array is actually the integer. So we need to convert this data type to a float data type. Now it becomes here a float. Once it is a float data type, then you can assign here np.nan and np.inf. Now I get here A equal to nan and inf. If you compare this A with inf or nan, you will get here a true value, but not here. So to do that, just to check that the nan values or a null values, you can write here np dot is nan, and there I say here array A. So it says that this value is nan, and that's where it is saying that here a true, and rest it is saying that it is a false there. Alright. Similarly, you can check here np dot is inf, and in that I pass here array A. Again it says that these are these are false and false, and then here it says that the true. Then here it is false, false and false. Alright, that means I said here is inf, it will give you a true value where the value of the array is inf. Alright, this is all about in this lesson. Thanks a lot for watching this. I'll see you next one. Hi everyone, let's go ahead and get started with the statistical operations into a Numpy. We are going to basically see here how you can get the mean, variance, standard deviation, median, minimum and the maximum values from the Numpy array. Let's go ahead and create a Numpy array. So I say here A equal to np dot array, and in this array I'm going to pass here 1, 2, 3, 4, 5 and 6, 7. This is just a random number, you can take any numbers. In this number I'm going to get first a mean. So to get the mean, you can simply say here A dot mean. You will automatically get here a mean value. So A dot mean is one way to do that. Another way to do that, you can do like np dot mean, in that you pass the array A. So in these both way, you can find out the mean value. Otherwise, if you take this list simply, suppose that you have a list and you want to get the mean value, you can simply pass this list where you will be getting the mean value. So these are the ways to get the mean value. Although this seems like a standard Python value, a standard Python method to get the mean. And here this one is a Numpy method to get the mean. Let's go ahead and similarly try to find out the variance of an array. So I say here a dot variance. So in that you get the here a variance. So again mean is 4 and variance is also 4 for this data. Let's go ahead and see standard deviation. So for standard deviation I say here std. So std is 2. A dot variance I'm gonna say 4 and std is 2. Let's go ahead and see what is the median of the value. So a dot median, and in this I think we did not get the correct result there. All right. Let me see how you can get the median. Anyway, seems like we are using a correct method. Otherwise, if this is not working, okay, so you can get here a standard Numpy way to get the median. Np dot median here, and in that you pass the array. So again it says that the median is 4. So the median is a number which is sorted into ascending or descending order, and middle value is a median. Now you see there the median and mean are equal for this particular data set. Similarly, if you have a multi-dimensional array, for example, if I create here a 2-dimensional array, so the same method you can apply into your 2-dimensional arrays as well. So I'm going to say here 11, 22, 33, 44, 55, 66, 77. This is a 2-dimensional array. So in this 2-dimensional array, if I say here a dot mean, now you see there you get the mean value of these whole numbers together. If you add the numbers and then divided by 14, you will get here a 24. Similarly, you say here np dot mean and you pass here array a, then again you get here a 24 value. So all the procedure which we did earlier, like np dot median, and in that you pass array a, it says that the median value of this array is 9 there. Alright, perfect. Similarly, you can do here for a standard deviation and variance as well, like a dot var, that is the variance, and again a dot std, there you do, this one is the standard deviation. Alright, perfect. So this is all about in this lecture. Thanks a lot for watching this. I'll see you in next one. Hi everyone, let's go ahead and see a Numpy shape, reshape, retrieval and flatten functionality. These methods are used to change the shape of array. In previous lecture, we had a shape of array as a 2D array, a Numpy array. Let's go ahead and check the dimension of this array. So it's ndim. With this you check the dimension. It says that it is a 2D array, and a.shape says that what is the shape of this array. So this says that the shape of array is 2 cross 7. That means there is 2 row and 7 column. If I ask you to reshape this array into like 14, 1 cross 14 column, then how would you do that? A dot reshape. Alright. So in this I say here a dot reshape 1 cross 14, then it becomes something like this. So here it has 1 column, it has 1 rows and 14 column. So do remember, when you are reshaping these values, so the reshape values should be, I mean to say that the multiplication of these values should be equal to the multiplication of these values. For example, if you reshape it to 1 cross 10, then you will get the error there, because a size of 14 array cannot be shaped into a 10. That means you have to have equal number of values in original array and reshaped array. And if you are not aware that how many columns it is gonna produce, so basically you can say that here a -1, that means make as many as columns you want but keep only one row. That means you can add here as many as columns you want, but you don't need to change here anything, because it will automatically take here as many as columns it want here. Similarly, you can use their rival. So the difference between reshape and rival is here. In reshape, you define here shape value there, but in rival you don't define the shape value. Whatever the array you pass, it automatically convert those array into one-dimensional array. For example, a dot rival, so it automatically converted this 2D array. Whatever array or whatever values we have there, these values got converted into 1D array. A simple array vector is produced here. A first row value it took, and thereafter it concatenated a second row value. Similarly, if you have 3 or 4 or as many row you want, it can concatenate all those rows together, and then finally it will produce you a one-dimensional vector there. Let's go ahead and see how you can use the flatten. So this rival and flatten work into a same way. So similarly you can use here a dot flatten. Now you see you are getting here a same result here. A very important difference between rival and flatten is rival returns a view of this array. That means whatever the array we return here, if we modify the array, returned array, it may change the original array. But flatten returns a copy. So in a Python, there are two ways to return a variable, either a copy or a view. A view is something, if you return a variable as a view, that means if you change a variable, it will change the original value. Otherwise, if it is a copy, then it will not change the original value. The change will apply to only a local values. Alright, this is all about in this lecture. Thanks a lot for watching this. I'll see you next one. Hi everyone. Let's go ahead and get started with the sequence, repetitions and random numbers in a Numpy. So sequence is like you are generating a list of the numbers. A repetition is like you are repeating a set of numbers to generate an Numpy array. We will first see here arrange. So arrange function is used to get the evenly spaced values within a given range. For example, if I say here arrange and you specify here values inside arrange like 1, 5, it is gonna give us, alright, it is going to be the np.arrange here. So np.arrange here, that should be AAR, it's like this. So the np.arrange, that means it is going to give us an array, a range array. So 1 to 5, that means it is going to give us a value between 1 to 5, a evenly spaced value, and this last value will be ignored here. 1, 2, 3, 4 is included there. Similarly, if I say here 11, then you will get a value from 1 to 10. Similarly, you can define here a data type to get your values. I say here integer or I say here a float. So if it is a float, you will be getting here a float. Otherwise, you can say here str. Seems like str is not available there, but yes, for float it works there. But if you are not satisfied with this range of values, you can also specify here the steps in which you want to generate. So the third parameter defines here the steps which you need to do here. If I give 1, then it is going to give us the same result what we got earlier. The reason is here, step 1, that's mean it is going to keep the difference between these two consecutive number as 1. But if I say here 2, it is going to keep the difference between these two consecutive number as the 2. So it starts from the 1 and plus 2 is the 3 plus 2 plus 2, and if it add 9 plus 2, then it becomes 11. But as we know that this does not include 11, that's why we are not seeing 11 here. Similarly, you can put here a 5 as well. So you will be seeing here 1 and 6 only, or whatever the numbers you put there, accordingly you will be getting here a range of values there. The another function which we are gonna see here, linspace. A linspace is linearly spaced values. Again, in this we define there numbers between starting and end numbers, and then we say that how many numbers we want. I'll tell you the difference. For example, if I ask you to generate, if I ask you to just change this range to linspace, then see what happens here. You know, by definition it seems linspace and a range is same, but actually these are not. The difference is here, if you define here 5, that's mean it is going to generate values between these two values, but the difference between these two consecutive value will be 5. But in linspace, it is going to generate values between these two, and it will include the last value, and another difference is here this one. So here we define that how many values we want. Earlier we were saying that what should be the difference between two consecutive number, but here we are saying that how many numbers we want. I said that I want a 5. So this line of code gave me a 5 number, 1, 2, 3, 4 and 5. And then these numbers are evenly spaced. Another difference between these two are, here you can control the difference between consecutive numbers, that's mean the gap between the consecutive number, but you cannot control how many numbers you want. In a linspace, you can control how many numbers you want, that's mean the size of array you can control, but you cannot control the differences between these two values. That's the major difference here. If you say here a 50, you are gonna get here a 50 values between 1 to 11 are evenly spaced values. Similarly, if you put here int, now you will be seeing there all the float values got converted into a integer numbers there. Alright, let's go ahead and see how we can use the random. So for a random, we need to import random first of all, and then we can generate the random values. Import random, alright, or from Numpy import random. So the both works in the same way. Alright, so I'm just going to remove that one. I got here a random. Now you put there a random, and then you hit here shift and double tab, you get the definition of the random. So it says that the random number generation, and it takes here, it says that these are actually generator, that's mean the algorithm which generates the random numbers. And then finally you come to the end of this somewhere here. You see that these are the APIs available into random, like rand, randn. These are uniformly distributed values, a normally distributed value, uniformly distributed floating point numbers, or something like that. So all these are available here. These are the distributions which you can generate by using the random numbers into a Numpy there. Alright. So for example, if I say here like random 1 to 10. All right. Okay. Random dot rand int actually. So it is going to give us the random numbers between these two values 1 to 10. Every time I run it, all these values will be in between 1 to 10. If I give here 1000, there is the probability that you will be getting the values between 1000 to this. Sometimes you may ask that how would you get the float values? So like let's say if you want to the float values, a random float values between 1 to 1000, you can simply either divide it by 100, you will start getting here a random float values. Similarly, you can get the normal distributions or uniform distributions as I said earlier. Let's go ahead and see the other functions like range function, then zeros and ones functions we will evaluate here. In a range function, range is something where you say that what is the range you want between these two. So this range is like a range. Alright. So earlier we saw this one. This range is also in the same way, but here it does not return any array, because this one is not the array of range. This is just a iterator there, a range. If you want this as the array, then you put here np dot array. It's something like this. So in the similar fashion, you will start getting a range and range in the same way. So earlier a range was like the array of a range there. Let's go ahead and see zeros there again, np dot zeros. So this comes into the definition of repetition. There was the generation and the repetition. So the repetition is something I'm saying that generate a list of zeros which I defined here rows and column. So it says that there is 1 row and 5 column. There is the 2 row and 5 column. And here it is a 5 row and 5 column, 1 2 3 4 5, 1 2 3 4 5. All right, so it has total 5 rows and 5 columns. That's the zeros there. Similarly, you can do with the ones as well, like np dot ones. Here if you define here only 1, it's going to give you a one-dimensional array. If you define here a 5, it is going to give you a one-dimensional array, a length of 5. Similarly, if you say here 5 cross 5, a two-dimensional array. But again, if you make it something like this, it is going to give you a three-dimensional array. You can check the shape of generated array. It says that 5 cross 5 and there is the 4. Alright. Perfect. In the last one, which we are gonna see here quickly, np.tile and np.repeat. Let's say you have here np.tile. In this I have these values and I want to repeat these similar values multiple times. So here I say here 2, that means this similar value will be repeated 2 times. If I say here a 20, the similar value will be concatenated a 20 times here in one-dimensional array there. Alright. Similarly, there is np dot repeat there. So this repeat also does the same thing here, but the difference is here tile takes this whole value and then concatenate this whole value as many as number you provided here. But in case of repeat, it is a little different. In case of repeat, it repeats these numbers as many times you define it here. That means this repeat 1 2 times at this place itself, and then 2 times at this place and 3 at this place. For example, if you give here a 20, so this 1 will be replaced 20 times first, and then 2 will be replaced 20 times first, and then 3. That's the major difference between repeat and tile. Alright, so this is all about in this lesson. Thanks a lot for watching this. I'll see you next one. Hi everyone, let's go ahead and get started with the where in a Numpy. Where is used as a filtering condition for a Numpy array. For example, if you have array A, something like this, and you want to filter out some part of this array by applying a condition, there you can use where. Let's say you have np dot where and you say that a greater than 10. So it's gonna get all the values which are greater than 10. So you get a result something like this. So where it says that in the first row you have something like this, where it says that np dot where a is greater than 10. Alright. Once you get the value something like this could be a confusion for you, but don't worry about that. This does not return the actual values, but these are actually returning here the index of these array. So it says that 1 0, that means this one is greater than 10, 1 1, 1 2, 1 3, 1 4, 1 5 and 1 6, all these are greater than 0. That means here you are getting index equal to like this, and if you say here a index, then you get here actual values which are greater than 10. Similarly, you can say here less than 10 and a is greater than 5. That means we are going to get these two values. Let's go ahead and run this. We need to put it something like this perhaps. Okay, again it says that this is this for more than 2 values is ambiguous. So you can apply it for 1 first and then you can apply it for 2. Alright, so it is going to do something like this. A np dot where a less than 10, that's the index, and then you are going to get this index. And second one, you can apply that again here, and that I'm gonna say is greater than 5, and then I say here index. But one thing you need to know that I need to put it here into a B, so that now I can filter it out with the B array. So it's something like this, and then I need to put it here a B. Now you see there our condition where we wanted a less than 10 and a greater than 5. We got the final result which says that it is 7 and 6 or 6 and 7 there. There are other ways where you want to replace the values. For example, I want to replace values with 0 which are greater than 50. How would you do that? It's very much simple. You need to just put here np dot where and I say here a greater than 50. If values are greater than 50, then I need to replace those values with the 0. Alright, I say here 0, otherwise a. Do you see there? So whenever this value, this condition satisfies, for those value, array will replace this value. And it says that there were 55, 66 and 77, those got replaced with the 0. If this is false, then it will replace with the same value. That's mean it will not change that. So anyway, these values were less than 50. That's why these values did not change there. And other than those, these 3 values got changed to 0 there. There are few more functions which I want to test before I close this lecture. Let's say if you want the maximum values from the array, as we had already seen a few lectures back, you can provide here a.max. But how would you get the index of maximum value if I ask you? You can simply say here a dot argmax, that's mean argument max. Here it is going to produce you. It says that the 13 number is the maximum value there. Alright, that's mean the value at index 13 is the maximum. And if you plot here, if you get the 13 one, you will get the out of bound axis. The reason is here, A is two-dimensional array, but when you say that you want to get the maximum argument, then in that case, it is going to produce you here a stacked version of the maximum value there. So to get the maximum value, you need to first flatten this array. So you need to put here a flatten there. Once it is flattened, then you can provide here a 13. There you will get the maximum value 77. That means it is here a dot max, which is 77 there. Similarly, you can get the minimum as well, a dot arg minimum. Alright, that's mean the minimum values argument, which is 0. And once again, as I did here earlier, in the same fashion, you can also get the minimum value. So there at the 0, and if you compare it with the minimum, you will get the same result as 1, because in the array which I defined earlier, in that 1 is the minimum and 77 is the maximum. Alright, this is all about in this lesson. Thanks a lot for watching this. I'll see you next one. Hi everyone. Let's go ahead and see how you can read and write Numpy array. For example, once again, we have our array A, and I want to first write this array. Now you see that in the data, we don't have array. These are the previous files which we did in previous section. In this section, we are going to write this array as a Numpy array. How would you do that? There are many ways to do this. Either you can write this as a Numpy array or CSV file or whatever you want. I'm gonna just say here np dot save, and in this you will get here a save. One is a save itself, and save txt and save z. So there are the differences to do this. If you do the save there, then it says that you need to give here a file, a open file, then you need to give here array, and then allow pickle is true. That's mean it will compress the data which you want to store the data. And first it will save the data into npy format, a numpy binary format. So that format you can simply save by writing np.save and the file name where you want to store and then the data. That means I want to store in the data a.npy. Alright, this is the Numpy array. And here the variable which I want to store, it is a. Let's go ahead and run this. I run this and here it is. Now you see that this array is there, but again this array is a compressed binary format. That's why we are not able to read this. Let's go ahead and see how you can save this array in a readable format. That you can do with np dot save txt. That's mean save this Numpy array as the text data. So that I'm gonna store into a data folder. I say here a dot csv, and then again I pass here my array which I'm going to save there, and the delimiter I want to store these values as a comma separated values. That is the delimiter. So delimiter, that's when the separation between these two values will be a comma there. I just run that, and if I open this now, you will be seeing that it is stored as a comma separated value. So this array was actually a two-dimensional array. That is why you have here 2 rows. If it was a single dimensional array, then it would have been just a single row there. Since it is two-dimensional, that's why you are getting there multiple rows. But what will happen if you have a 3 or 4 dimensional array? Let's go ahead and check that. You have np.array, And in this np.array, I'm gonna create here a list of 2D array, that's mean A and A. Now you check this B, this become here a 3-dimensional array. You can check this with ndim as well, or you can say here b.shape. This is a 3-dimensional array. Let's go ahead and save this 3-dimensional array. I say here b.csv and then here a b. I run this, but it says that here expected 1D or 2D array, but it got 3D array. So what's the problem here? Problem is in CSV file, you cannot save a 3-dimensional array. Only 1 and 2-dimensional array is allowed here. But if you want to store here a 3-dimensional array, then you need to change your method. So you need to bring this one at the top, and there I say that b.npy and b. Now this one you would be able to store because this one is original NumPy array format. But a 3-dimensional or more than 3-dimensional array you cannot store as the text file. Once these arrays are saved into a file, you can similarly read these array. For example, if I say here AA equal to np dot load txt. So I'm going to load here the text one. So there I have a data / a dot txt. Now you see there this a, wait a second, it says that data a dot txt is not found. The reason is here, I think I missed here. Okay, earlier it was saved actually the CSV, it was not the txt. So it was like this. And the delimiter I also need to define here. The delimiter is a comma. Now you see that this array got loaded into a 2-dimensional array once again, what we had earlier there. In the similar fashion, you can also read a npy array, that means a NumPy array, a.npy or b.npy. So it's again np.load and then I say here data / a dot npy. Now you see that the original array it loaded here. The difference here you see, when we stored our integer data, it got converted into a float. If we store it as the text data, that means as a CSV data. But if we store it as a NumPy array itself, whatever the data we wrote earlier, exactly the same data we are getting here. In the similar fashion, we can also read here a B array as well. That means b.npy. There you get something like this. b.npy, that means it is again a 3-dimensional array what we had created earlier. So the same type of array we read here and we wrote the same type of array. So what's the difference between save z and save txt? You can simply put your cursor between these two braces and then press your shift and double tab. Then you will see that this says that the save several arrays into a single file in uncompressed .npz format. That means if you have A, B, C, D, so many arrays together, you can store all those arrays together in one go itself. Alright, for example, you can simply do it like this. Data a.npz, and here I pass my A array and B array. Let's go ahead and save this. Now you see there I got here this array there, and similarly you can do here np.load, and in that you can load these data. So you can simply select here load, np.load, and there I say here a data a.npz, something like this. Now you see you got here a 2 file. So in these 2 files there are actually ways to get this. For example, I say here d equal to like this, and d dot you get here the files. Alright, so these are the files which we have currently inside this. One is the array 0 and another one is the array 1. So I say here d, and then I get here the first one. So this one is first array, and similarly I say here d, and then I take here array 1, that's the second one. Now you see that here the difference. The save Z can save a multiple array together irrespective of the size of those arrays. It is not necessarily that these two arrays should be the same size. That is not required here. There are two arrays. Whatever the size of those array is sufficient to get it stored as a NumPy array there. Alright, this is all about in this lesson. Thanks a lot for watching this. I'll see you in next one. Hi everyone, let's go ahead and see how you can do a NumPy concatenation and sorting. We have our previous array A, which is a two-dimensional array. It has total 14 values. That means the shape of this array is 2 cross 7. Now I need to concatenate this array, the same type of array, 2 times. How would you do that? Previously we had seen that how you can do the repeat, how you can do the tile, but here we are not talking about the repeat and tile. We are talking about if you have a multiple array. Otherwise, we can do something like this. Let's say I have here array 1, 2, 3 and 4. Array B I have here again np dot array, and in this I have here 3, 4, 5 and 6. Then I have here a C array. In a C array I say here np dot array, and in this array I have some random values here, something like this. Out of these 3 array, let's go ahead combine these 3 array together. That the process of combining these array together is known as concatenation, that you can do with np.concat. So np.concatenate, then you need to pass here a list of array which you want to merge together or which you want to concatenate together. So a list of array, I want A and B first time. Let's go ahead and see what happens. So this array and these two array got concatenated to each other. Now you see 1, 2, 3, 4, that is the array A, and thereafter array B got here merged into array A. Similarly, you can add as many as array you want. I'm gonna put here array C as well. So now you see there the array C also got concatenated into the original array. If you don't define here any axis, automatically it append these array horizontally. That means automatically it append all these array together in a single axis. The by default axis is here a 0. That's mean the same thing you are gonna get here. If you provide here a -1, that means it is gonna also add in the same axis. Let's go ahead and store this into another array here. X is equal to something like this. Then this X we have got here one-dimensional array. Now we are going to do here a sort listing of these array. So you can simply provide here x.sort. It is going to sort this array there. Alright, now you see there 1, 1, 2, 3, 3, 4, 4, 5 or whatever the value we had given here. All these got shortlisted here in ascending order. Let's go ahead and see how you can merge two-dimensional array together. So here we have our vector A, which is one-dimensional array. Now I'm going to create this as a two-dimensional array. So np.array, and in that I'm going to provide here A, comma A. Alright, otherwise I'm just going to do here A, comma C, probably that would be better. Now this B, you see that it has become here a two-dimensional vector. You can check here ndim of the B, which is saying here it is a two-dimensional vector. So this two-dimensional vector, you can also perform here a concatenation, np.concatenate. In that, you need to also provide here a list of the vectors which you want to concatenate together. For example, I provide here A and B. You will get the error. The reason is here we don't have a same axis vector there, because this A is actually a one-dimensional vector, but B is a two-dimensional vector. So how would you do this? I'm just gonna get here our vector A as a two-dimensional vector as well. So I say here A equal to np dot array, and in this I'm gonna say here I need A and C, which was previously given there. Now you check your array A vector. This is the array A. So this is also now a two-dimensional vector, and array B was also a two-dimensional vector. Now I'm gonna do here concatenation of these 2D vectors. Now this time it has successfully concatenated these two vectors together. Now you see the difference here, what happens there. Earlier we saw there all these got concatenated on a single row. The same thing is happening here. You see there we had here a single row. In these vectors we have a multiple row here, this row and this row. Now you see there the same thing is happening here. Alright, so all these got concatenated into a single row there, right? Alright, so it's like this. If I do here x equal to something like this, you check there x, and here x0 is first vector, and then x1, then x3, that's the last vector. So you can access these as element wise element. If you reduce these to a single element, now you will be seeing that it is just a simple vector, a single vector. Let's go ahead and do these concatenation on other axis, like axis equal to 1, then see what happens here. Axis equal to 1. Now once we do here axis equal to 1, these vectors got concatenated on each other based on their rows there. Now you see the first vector, A vector. If you print here, the A vector is there, 1, 2, 3, 4. Then you have 3, 12, 4 and 1. Alright, so this one is the A vector, and this B vector is coming there. So when you define axis equal to 1, that means you are appending columns, additional columns there. But if you don't define axis equal to 1, or you define axis 0 or minus 1, then you are effectively adding there the number of rows there. You see there 1 row, 2 row, 3 and 4 rows there, something like that. Let's go ahead and see how you can convert these vectors into a horizontally stacked and vertically stacked vector. So there is another process to do that, which is known as VStack. So in VStack we also provide here the list of the vectors which we want to stack together. This says that this is a vertically stacked vector. So here you had A vector, and on the A vector, vector B got stacked there. So we are stacking vector B over vector A, or you can say a vector A over vector B. This is a vertical stacking. Similarly, you can use there a horizontal stacking, which is known as H stack. np.h stack, in that I have A and B. It is going to horizontally stack to each other, 1, 2, 3, 4, 1, 2, 3, 4, like that. So you have this, and then you have these two there. So that's how you see you can stack vectors together, vertical vectors and horizontal vectors together into a Numpy. Alright, this is all about in this lesson. Thanks a lot for watching this. I'll see you in next one.